Okay, guys. Ali has just joined. Anesu, are you okay there, honorable member? Ali, what I was doing now before you joined, I was speaking with Mendlong. He's writing English tomorrow. So, I just made him aware that in case if he is familiar with the topic, then he is allowed to leave and prepare for his English. So just in case if most or all of you guys are writing either tomorrow or the day after, um, do not feel guilty of not attending today's lesson. You need to make sure that you prepare for the lesson. This is actually meant for those who prepared, not necessarily prepared, but those who requested for this topic. And again, those who are yet to write physical sciences. So, Anesu, are you not yet done with physical sciences?
I haven't written, sir.
Say that again.
I haven't written the exam, sir.
Oh, okay. But are you not writing something maybe tomorrow or a day after tomorrow?
I'm writing physics day after tomorrow, sir.
Okay, I see. I see. The Alice, I think yourself, you're not yet done with physics, are you?
No, sir, I'm writing that like next week Friday, and then the week after Monday.
Okay. All right, I see. Then it's fine. It's fine. It's fine. It's fine. I've got something there for you guys. Recheck if you can be able to answer this question. The first question there, you are requested to calculate the total resistance. So that means in this case, you will have to then very quickly work it out, and then from there, let me know what the answer is. Then we will compare our answers. The thing that I forgot to do here, it is to allocate marks for each of these questions. This one, it deserves 5 marks. Reading, 3 marks. Reading one. Yes. Okay. Yes, this is the question, honorable members. Guys, did you get my question on that one?
Yes, sir.
Yes, sir.
Okay, then it's fine. You can work it out. Just the first question, and then once you get an answer, you can unmute and let me know what you get as your answer for that question.
Sir, I'm getting 3.5.
You are getting
3.5, sir.
3.5 ohms. The other honorable member, what are you getting? Let's see if there's another one who's joined. So Alice, you say 3.50.
Yes, sir, that's what I'm getting.
Okay, then it's fine. A honorable member requested for the lesson to be recorded. Yes. Anesu, what are you getting on your side?
So I got 3.75.
3.75. Okay. Okay, maybe Anesu, let me start with you. Can you explain on your side what you have done? Or how did you do it?
So I first calculated the resistors in parallel, and then I calculated the resistors in series.
Okay, so in parallel, the parallel one, how did you work it out?
It's 1 over R equals to 1 over 1 over plus 1 over 1. So it's like 1 plus 1.
Wait, wait. Can you repeat that part? The honorable member, the one for the parallel. You said, what did you do?
Say 1 over RT equals to 1 plus 1.
1 over RT is equals to 1 over, maybe let me write it down, just so that I am following. So you see 1 over RT.
Yes, sir.
You said it's equals to what?
So say it's 1 over 1, which is basically 1, plus 1 over 1 again, sir. Yes.
Which is 1. So that means your RT is equals to 1 ohm for the R parallel.
Yes, sir.
Then you, okay, continue. And then from there, what happened?
So then I calculated the resistors in series.
Okay, what is the answer?
So
Or how do you substitute on the formula? What do you write?
so it's 1 plus 1.5 plus 2.
Okay. Because this is equals to 3 ohms then. It's 3? No. It's 4.5. That is 4.5. Okay, the Alice, what about on your side? How did you work it out?
So what I did was that I first calculated the parallel section.
Okay, how did you work it out?
The equation 1 over R parallel is equal to 1 over 2 ohms plus, and because the other two together are in series, I added them together to be 2, and then I said, and then I added that to the normal equation 1 over 2. So in total, I got 1 over R parallel is equal to 1 over 2 plus 1 over 2.
So your 1 over R parallel, you got it to be what? Half plus
So I
half,
got
which
it.
is 1.
Yes, sir. And then
Okay.
what I did was for total resistance, I added the parallel one, the total parallel, plus 1 over 5 plus 1 ohms, because those are the others in series. And then I got
Okay.
3.5 ohms.
Okay. That makes perfect sense. Maybe let me quickly explain to the honorable member. Anesu, are you still there, honorable member? I want to explain something very much important so that you will understand how it works. Are you still there?
Yes, sir.
Okay, let me explain it to you. You know, the tricky part here, this is what happens. We only have one formula to calculate R tot. Can you hear me on this one, Anesu?
Can you repeat that, sir?
So the only formula to calculate R tot is the one for calculating the series. That is the formula to calculate R tot, the total resistance. So what resistors are connected in series is that one and that one. Do you agree?
Yes, sir.
Then you will say 1 plus 1 comma 5 plus this one that you need to substitute there. It is the one which is connected in parallel, which you need to serialize or convert it from being parallel to being series. Do you get it now, Anis?
I think so.
Then now it means you need to calculate R parallel. What is the formula for R parallel? Is 1 over R parallel, which is equals to 1 over R1 plus 1 over R2. So what I'm saying, Anesu, is that we don't have 1 over R tot. This is not R tot, but it is R parallel. The only formula for R tot is that one. Does it make sense now, Anesu?
Yes, yes, sir.
This is R parallel, not R total. So how you do it, you say 1 over. Can you see this 2? It is nicely in a parallel, so you write it over 2 there. But you see there on that other one, inside that parallel, you still have series. Can you see the 1 and 1? So
Yes.
what you do, you must add them together. You add them inside that formula there, just so that it's a single resistor connected in parallel, just like that 2. So that 2, maybe before it was 2, it was maybe 1 and 1, or it was 0, 5 and 1, 5. Then it was combined to be 2, but those two are not combined. So you must combine them to make it a single one, because it's a series inside parallel. That's why there we are adding them in a series form inside the parallel. Does it make sense there, Anis?
Yes, it does, sir.
So now you have 1 over R parallel, which is equals to, this is half. Also, this will be 1 over 2. Can you see? Half plus half is 1. So that means you have 1 over R parallel, which is equals to 1. It doesn't end there. What you need to do now, you can say you do that over 1, then you cross multiply, meaning you have R parallel, which is equals to 1 ohm. Then that's when you are going to take this one and you will substitute it into that formula for calculating R tot. Then it means you now have your R tot, which is equals to, you said 1, that you must plus it with 1 comma, sorry, 5, now you plus it with 1, and then you have 1 plus 1 is 2, 1.5 is 3.5. That's why Ali is getting 3.5. You can say 0 there, just so that it's in 2 decimal places. Does it now make sense, Anesu? Do you fully understand how it works now?
Yes, sir.
Good, good, goodest. let's not lose that answer. Maybe let's write it down and then, okay, we did write it down. Let's move on to the next one. Very quickly work out the next one and see how far you can go with that one. So these are the basics that you need to master. If you can master these basics, trust me, when you get to exam questions, if you could remember these basics, you won't be in trouble, because these are the most important basics that you must know before you do any complicated problems. So now the reading on A, that's what they want you to calculate. And that question is allocated 3 marks.
Sir,
Mm-hmm.
I got 5.71 amps.
5.71 amps. Okay, that it's fine. Let's wait for Anesu. In the meantime, you can look at those other
I
questions.
also got 5.71.
5.71. Okay. It shouldn't be a complicated question. I would agree with you on that one. So 5.71 that. Okay. What about the reading on A2?
So I got 2.86 amps. I didn't round off. I used just decimals in the first one to get the second answer. So it looks different, but I rounded it up.
Wait, are you on number 3 now, A2?
Yes, I finished this thing while you were explaining to him.
Okay, and then what did you do on A2?
So, sir, on A2, we can see that the amps is right next to the voltage. It's not connected to anything. It's in the series section, so it would remain the same. And so I used the total resistance of the circuit, which is 3.5 amps, and I used the voltage of 20 volts from the battery and I used the equation V equals to IR. So I subbed in the voltage and resistance, and then I solved for I, which I got 5.71 amps.
So are we now on A2?
Yes, sir, this one's A2.
Okay, 5.71.
Yes, sir.
Okay, let's see. Anesu, what about on your side, honorable member? What did you get on your side?
So I got a different answer, but that's because I didn't use the R total like he did.
Okay, what did you get?
So I got 2.67.
2.67. I'm tempted to say this is correct. It looks like the correct. Can you
Sir, is
explain
this
what
A2,
you did?
sir?
Yes, we're now on A2.
Oh, sir, for A2, what I got was 2.86.
2.86. Let's
Yes, sir,
update
sorry.
that. Let's see.
I thought you were still asking about number 2.
Okay, no, I see. 2.86. Then which one is correct now? Then you might need to explain what you've done there.
Sir, for 2.8.
Okay, wait, the Malis, wait. Let's see, Anesu, well, how did you work it out? Anesu, how did you work it out? I'm not sure if Anesu is still there. Okay, he's out. No, it's fine. He is out. Okay, the Alice, you can explain, how did you work it out?
So, sir, for I got 2.86 by calculating the total by, I took the amps that were already there. I mean, wait, what?
Mm.
No, let me check. So, A2, I said was 5.71, the total amount of amps divided by 2, because the resistance in both of them was the same. And the voltage would also be the same because it doesn't split in parallel. So the resistance for the amps to go through would be the same. So I just said divided by 2, and I got 2.86.
Wait, Alice, can you explain again that part? I had something I want you to correct it, but correct it by re-explaining. Let's see. Let's see.
I got disconnected there.
Okay, then it's fine. Anesu, explain what you did there.
So first I calculated the voltage that is in parallel, and then I used that multiplied by the total current in parallel, total resistance in parallel to get the current.
Wait, you started by saying you used what?
So I calculated the voltage that is in parallel.
Oh, the voltage. The voltage in parallel, how did you calculate it?
So I used the formula V equals to IR.
The I was A1.
Yes.
And then that was R parallel, which was that. Okay, makes sense. And then from there, it is okay. Okay. Both of you, you've done it, let's say correctly, but with you, Anesu, you went the longer route. Can you see that question? It was allocated 2 marks. So there is another easier way of working it out, but how you did it, you are 100% correct. It's just the issue of roundings there from what I'm seeing. Let me explain that easier way. So if you look at that, you will actually notice
I can see a screen.
Let me check. On my side, it says it's sharing. Maybe let me stop and share it again. Let me share it again. No. Still not sharing.
I can see now, sir.
Yes. So what I was saying was, this is how the current flows. The current will flow through there. Maybe let me do something on that one. The current will flow like this. When it gets there, it splits. Do you agree, Anesu?
Yes, sir.
So in these instances, what you need to do before you do any calculations, you ask yourself a question to say, how will this current split? Will more current go on that other side and then less on the other side? And which current will go, which side will receive more current and which side will receive less current, and what will be the reasons? Let's discuss this part, and this before we do the calculations. As it splits, will it split equally or not equally?
So not equally.
Why not equally?
So one side is more resistance than the other.
Okay, which side has more resistance?
So the one with the 1.5 ohms.
The one with
1.5 ohms.
Mm, 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 mm. So when you say 1.5 ohms, are you referring to that one?
Yes, sir.
Okay, then I'll have to redo these so that you will now be able to visualize it, because if you won't get this part, then you won't survive. You see what I'm drawing there in yellow?
Yes, sir.
That represents the current. So when it gets to parallel, this is the only place where it splits. Can you see? This is the only place where it splits. And then when it gets there, it joins again. It goes back to normal. Can you see, Anisu?
Yes, sir.
Yes, it's like hose pipe. It's like water flowing like that. When it gets there, the other water will flow through that side, other water flow that side, and then it goes back to join again. So that means the current that is passing through there, it is the same current passing through there, everywhere along series. Why? Because it didn't split along the series. It only splits on the parallel. Does it make sense, Anisu?
Yes, it does, sir.
So the question is, as it splits, will it split equally or unequally?
Equally, sir.
So that means you just take that total, you divide it by 2. You don't do much. You just divide it by 2. That's what Ali did there. So that you cut it into half, and then half that side, half that side. Does it make sense?
Yes, sir.
So you won't get it wrong. Now you fully understand it, most, Anis.
So, sir, can I ask,
Yes.
if one side has more resistance, does that mean it doesn't split equally?
Yes, it doesn't split equally.
Okay, thank you, sir.
So you need to be able to then visualize it. The question now is, now that you know it won't be splitting equally, which side will receive more current? Because it doesn't end there. Let's say we have this 5 ohms, 1 ohm. Which side will receive more current?
5 ohms, sir.
Okay. What will be the reason?
More resistance.
Okay, so now let's discuss. The word resistance, the word itself, resistance, what does it mean? Does resistance allow something to pass through, or does it oppose it to pass through?
It opposes it.
Yeah, so that means this side opposes too much current. Therefore, more current will pass through where there is less resistance. Just think of it, the Ma'alis, these are the soldiers. They need to get to this side. Will they go through this side which has too much resistance? No, there are too many soldiers resisting them to pass on that side. What they will do, it is to go through this side with less resistance. So that means this side will read more current, it will flow through this side, but a very little current will flow through that side. Does it make sense?
Yes, sir.
Good, goodest. Now let's see. Okay, the reading on V1 and V2. Are you sure you understand, Anisu? Does it make sense?
Yes, I understand, sir.
Okay. A reading on V1 and V2.
Should I give my answer now, sir? Should I just wait a little later?
No, I think it's fine while Anisu is still working it out on his side.
So for V1, what I got was 2.86 volts, and for V2, what I got was 5.71 volts.
Okay, let me write it down. You are saying for V1, what did you get?
I got 2.86, sir.
2.86 volts. Okay, for V2.
I got 5.71, sir.
5.71 volts. Okay, then it's fine. Anesu, are you still working it out? Let me see if there's someone else who has joined. No, still
Sir,
the two of us.
I really don't know how to do this one. I'm not sure how to do this one, sir.
Okay. Okay. It is meant to be a tricky one, but looks like the Maalis managed to work it out. Okay, but do you agree that Anis, do you agree that the reading on ammeter 2, we will just take that and we'll just divide it by 2, and it gives us 2.86. Do you agree there?
Yes, sir.
Okay, now let's talk about a V1. What is the formula for calculating V?
So is it I equals to V over R?
Hmm?
So V equals
Is breaking. You're breaking the Anesu. What is it, Anesu?
so me the formula that I usually use is I equals to V over R.
Okay, but what about the formula for calculating V?
I'm not sure, sir.
Okay, it's fine. Let's go on that one. You say I is equals to what? V over R.
Yes, sir.
Because this formula, it's coming from this one. You just need to multiply that by that. It's like I'm saying, make V the subject of the formula. So that means V is equals to IR. So you must know this formula, then you will be able to calculate either I or R, because this one that you know, it comes from that one. Does it make sense?
Yes, sir, it does.
Okay, so for V1, what is the current that is passing through that resistor where V1 is connected? What is the current passing through there?
Is it 2.86, sir?
Yes, it's 2.86. That is the current that is passing through there. What is the R? It is 1. Then what is that times that? It remains as 2.86 volts. That's how Ali calculated it. Does it make sense?
Yes, sir.
So you would not be able to calculate it if you can't formulate that. So that's why I was saying, forget about that formula, because you see now, you do have that formula, but you can't use it to formulate V. So you must know that that formula, you can still make V the subject of the formula, or make R the subject of the formula. So now that we have V1, what will then be a V2? Do you have an idea, or is it also difficult, that one?
So do you take the same current and then multiply it by 2, since there's like 2 resistance there?
That should be the way. It can be done in many ways. It can be done in many ways, because the Ma'alis maybe come in. What did you do there?
So, sir, I used the equation V is equal to IR, and because we've already calculated because V2 includes the entire circuit,
The
I
entire
used,
parallel.
yes, sir, the entire parallel. That's what I meant. I used the current of 5.71 amps, and because it's a parallel, the resistance, it's placed parallel. I used the 1 ohm that we've already calculated from it, and so
100%.
multiplied both of them together to get 5.71 volts.
So that is the first way you can work it out. The second way, this is what you must always know. You must know that, you see where that V2 is connected. The V for that V2, it is the same as the V for this 2 ohms. So I'm just saying, where it is connected, it is the same as the V that you will get on the 2 ohm resistor. Means even if you say that 2, it should give you the same answer. It may be different because of the roundings, but you can still do it that way. That would be the second way of working it out. Does it make sense?
Yes, it does.
Again, what you can do, you already know what is the V there. It should be the same as that V there. Then you combine them together. Then that combined V, it should be the same as that one there. It should be the same as that one there on the 2. So in short, this is what you just need to know, honorable members. When it comes to parallel, a lot of things can be done there, but it doesn't change much. If you have V there, let's say a V1 there, this is parallel. If you have a V that there and that there, and then they say this is a V2, and then let's say this is a V3. Let's say this is V4. This is what happens, honorable members. The reading on that V, it is the same as the reading on that. It is still the same as the reading on that, because this reading, it combines two. But it cannot be the same as the reading as that individual, because this one, it reads that single one within that series, which is inside the parallel. So otherwise, you are forced to also know the reading on that one, then you combine them together, and it will be the reading there, which will be the same the reading as there. It should be the same reading as there. So that means if you can know the reading on there, automatically you know the reading for the whole of that parallel connection. And automatically you know the reading for the opposite side of that parallel connection. I'm not sure if you get this one, honorable members, because it's very much important to know this. If you don't, then you're going to be in trouble. I'm not sure. Does it make sense, members of parliament?
Yes, it does.
Yes.
Are you guys sure that you fully understand what I've explained there?
Can you just explain it once more, sir, just to make sure?
Okay. I do think I need to repeat that part. Okay, so this is what happens, the Ma'alis. we have a circuit there, and then inside that circuit, we also have a series there. So what I was saying was, here, let's say we have that, we also have that. So a V can be connected in many ways. You just need to know that it doesn't change. You see V1 there, that V1, if you know or you are able to calculate the V1 for this side of the parallel, just know that it is the same for this other resistor. And again, it is the same as if it was connected for the whole of that. That's what I'm saying. Does it make sense?
Yes, sir. Because
Yes,
it doesn't
but
change in parallel.
yes, it doesn't change in parallel. But the moment in parallel, inside that parallel, the moment you have series, then things change. Let's say you have that one there, you also have that one there. So what I'm saying now is, what is it? What I'm now saying is that for that V not to change, it must have been connected to both of these. But if it is not connected to both, and if it is connected to just that one, let's say it's V2, then V1 and V2 are not the same. Do you guys get that part? That's what I'm trying to explain.
Yes, sir, that makes sense. Because it's only
Yes,
a portion. It's
it's
not
only
the
a
full,
portion.
not the full thing.
Yes, not the full side of the parallel, or not the total side of the parallel. Anesu, did you also get it on your side?
Yes, I understand.
Yes, 100%. Okay, guys, I think we can leave it here. That's what I wanted us to go through in today's lessons. Unfortunately, the person who requested for this lesson did not join, but I've made this recording available. Yeah, it will be available after the lesson, and then they can catch up. Okay, guys, very quickly, let me run away. The Alice, I'll just drop your WhatsApp now. Yeah. Okay, guys. So, Anesu, I think you're the one honorable member who needed this information the most. Do you not have any questions for me before I run away?
No, sir, you've helped me with everything.
Okay, 100%. Then Alice, no questions from your side.
I don't have any, sir.